Video so that you guys have something to see.
Hello. Those days are over for me. Countless hours or even days spent provisioning networking tasks and then troubleshooting on a per switch, per port, and even per cloud basis. But as you saw with Cisco ACI, the frustrations and inefficiencies go away. I now have a central point of management that automates many of those tasks, providing consistent security anywhere. Cisco ACI brings immediate value to any size network. Start with a small portion and grow the fabric to hundreds of switches, even in multiple locations. Again, keeping that one central point of management. Bring Cisco ACI simplicity to your network. Start today at www.cisco.com/go/ACI.
All right, so I think it's 5 minutes past, so welcome, good morning. I'm glad you made it today. My name is Carlos Campos. I'm the Worldwide Data Center Switching Technical Lead for the sales organization. So I'm very, very happy to be here with you guys today. The idea is to cover a little bit of all the technologies that exist, or pretty much almost all the technologies that exist as part of our data center portfolio. That, as we saw before, it's not a data center anymore. It's just pretty much spread out everywhere. So it covers several technologies, right? It covers virtualization, it covers containers, it's bare metal, it's now analytics and security and cloud. So it's just so much that we will see today that hopefully I will try to make it as interactive and as demo-based as possible. That's part of the idea today. So we're gonna take a look into the full data center architecture picture. I'm going to be splitting the screen a little bit. As you see, we have a lot of tabs over there. So that's all the elements we will see today, starting from the ground up, from the plumbing layer all the way to the analytics layer and security, and then finishing with the multi-cloud approach, right? So first we're going to see so we're going to do some sort of use cases, by the way. What I did is I simulated that we're owners of a new online retail company, and we have our online store on the web, and we're going to see how that company will suffer different challenges throughout time. First, high availability, then we're going to go through growth, through some growth challenges, then security and compliance, last but not least, or actually it's not last but not least, then cost optimization and multi-cloud, how we can embrace or integrate the cloud environment into our premises, and the last part, how we can start doing a top application-driven orchestration, if you will, with a single-click experience. So let's get started. Please interrupt me anytime, any questions you may have, let me know. Also at the very end, by the way, I'm also going to be covering, I didn't put it there, just some other cross-architecture integrations. And even, I want to be totally honest with you, sometimes we really want to make sure that you get the best out of our underlay and overlay integration. And we've had a lot of questions regarding some of you that may be doing sometimes NSX and sometimes ACI. So at the very end, I'm going to try to cover that so that you guys see how they can both fit together and what each of them can bring to the table, all right? So hopefully, again, we will cover all of that in the next 2 hours. I'm going to do my best to keep you awake. I know 2 hours is a lot, but let's hope that we can get this going. So the first part is software-defined infrastructure, right? We all know that that is something that is there, that is needed, that abstracts the full hardware or even the hypervisor layer and makes us have a single pane of management for different types of technologies. In this case, our approach is you always need the hardware, right? There's no technology, no software technology that can live without the hardware. And that's the same reason why we keep choosing an iPhone or a Samsung. We have a phone that you like because you like the experience, the reliability, and so on, but you also want that SIM card that may be able to fit into each device based on your requirements, right? So that's the same approach with this. We need a reliable hardware, and then if we can have a software-defined networking or software-defined compute or software-defined storage approach, that is great because that makes us centralize, as I said, administration of everything, but at the same time grow through time and automation, right? So again, the plumbing is always needed there, right? You will always, regardless you go to the cloud or go container-based or one hypervisor or the other one, you will always need to communicate on the network, you will need to process information, and you will need to store everywhere or everything somewhere, right? So what we wanted is, well, if we have a single pane of management, pane of glass for everything, it doesn't matter if it's a 100 meg port today or a 400 gig port tomorrow. It doesn't matter if it's an Intel version 1 today and tomorrow it's a new Skylake type of processor, or if it's a software, an SSD or MBE type of drive. That's a how, but again, the configuration is just done once, right? With that being said, then we need to embrace the cloud. So again, the cloud has also these plumbing layers, and we want to make sure that it's not inconsistent between on-premises and off-premises configurations, right? So that's what we did with the software-defined infrastructure approach. Then we have the analytics layer. If you have, whether you have or not Cisco infrastructure underneath, we want to make sure that you just leverage analytics to the maximum. So if you think about Netflix and the way they used to move, or they moved from just distributing content into producing their own content, you remember the series House of Cards. Now Kevin Spacey's probably not there anymore, but still, once we realized that we could profit because we know what the users are clicking on, then it was easier for them to minimize risk. So it's exactly the same thing. We have the platform, right? We have a network, we have a storage, we have compute. If we can know what our users are doing and how we can probably assure that every configuration is correct, or that I am using the right amount of resources every single time, not wasting them. We're oftenly providing or provisioning more CPU, more memory, more disk than what we need. So if an analytic can let me know how to right-size every load, or even provide zero trust approaches, instead of opening 65,535 ports, TCP and then UDP, just help me understand how my applications communicate and only open those. That's called zero trust or whitelisting. And last part, user experience. I want to know if I am moving to applications, most of you are already doing applications anyways, right? So if it's a hotel, for example, you might be trying to, I usually stay at the Sheraton or SPG, and I like the fact that I can go with my cell phone and just open the door. I don't need to check in or check out. So that's a differentiator for me. Or banks. I think you would never open an account if you didn't have the chance to do your transfers and check your balance on your cell phone, right? So most of us are now becoming software developers as well. And it is very important for us to measure that experience that you have, even from your cell phone, in this case your users, all the way to the database, right? So that's what App Dynamics does, for example. And last but not least, that single-click experience we always want. I want a new web server. I want a new database. Well, it would be great if I can just click once and choose which cloud I need, and based on that, it can tell me where it fits better, what the best cost is, and so on. So that's exactly what we did now. Oh, I'm sorry, the Azure Stack logo is somehow weird there, but that's what we tried to do there. So for networking, we have ACI Anywhere. Hyperflex, we have, storage, we have Hyperflex / backup. I would say that integration with Beam or Commvault and all those are there. Then UCS with compute. Last, the network assurance engine is the assurance analytics part, optimization with CWAM, and so on. So what I thought the best way for us to present and cover all this picture is through, as I said, a startup, just a company, right? Just like you guys. So in our case, our company is called SCVT Inc. Basically, this company is an online retail store, right? So this is just an application initially that is a web application that sells different things, right? So in this case, we will sell phones and we will sell backpacks and other things, right? So let me actually refresh this. There you go. So we sell iPhones, we sell backpacks, we sell all sorts of things, right? So again, this is the business. And for us, this is going to be obviously based on an infrastructure underneath, which is going to be storage, compute, as well as networking. And we will want to make it simple, agile, secure, and on demand. We want to make sure that as we grow through times and challenges that I will present today, that all these great solutions that are software defined will help me in thriving through those challenges. So with that being said, let's first start with our first use case. First, high availability. So I'm just going to go with the initial topology that we have for today's startup. This is the way we will start as a company. So obviously, we want some sort of high availability and redundancy between sites. For now, I have my applications where my users are accessing, which is what you saw over here. And I am, as the network, I am using ACI. For ACI, I have two different pods. That's one of the implementations we use within ACI, which allows you to extend layer 2 connectivity while maintaining a single pane of glass. Just think of ACI as a big switch. That's pretty much the way I think it, right? Obviously, it has other benefits, but if you start by remembering how you did it stack-wise, at some point you remember all these switches stacked up together, or BSS with 6500. If you just think about ACI going in that concept, but now with asteroids, you're going all the way to hundreds and hundreds of switches potentially, although you can start very small, and you can integrate virtual, container-based, and cloud-based networking, right? So it's a single pane of management for all things networking. In our case, initially, we will see that this is covering ACI in a multi-pod setup. For our first pod, it's based out in Miami. We're having multiple hypervisors, because again, we're trying to be agnostic to everything, and we have VMware, we have Hyper-V, we have Red Hat, and then we're managing all those server infrastructure through something called Intersight. That's our software as a service-based solution for monitoring everything regarding compute and hyperconvergence. And then we have, obviously, conversion stacks, right? We have fiber channel connectivity using MDS 9000, and we're going to be connecting to NetApp, to Pure Storage, and so on. The second pod, which is very, very close by, it's in Fort Lauderdale. Fort Lauderdale is a city that is like 30 minutes away, probably from Miami. So we're in a metropolitan area type of network. Multi-pod requires 50 milliseconds or less in round-trip time. So we can comply with that very easily. And we're extending layer 2, making sure we have a dual data center scenario in an active-active fashion. And over there, I have Hyperflex. So I have hyperconvergency running with VMware, as well as CCP, which is my Docker-based container platform, right, using Kubernetes. So in this case, I'm also providing integration to the fiber channel environment. If you remember, hyperconvergency just takes CPU, memory, and disk, and clusters them all together to have a pool of resources, right? And you can scale them as you need. But you can also integrate that to your existing SAN. So that's a really, really good advantage we have with Hyperflex, that you can move loads back and forth if you need through storage vMotion, for example. So this is our baseline. Make sense? Right? All right. So let's see how this fits. By the way, our application is load balanced by a Citrix NetScaler. And every time we access our application, you will see that depending on your lock, basically, or the round-robin process, you will be routed through Docker in this case, or you can go and hit VMware or Hyper-V or Red Hat or any of the other environments we saw. So that's exactly what I'm going to just show you today, right now. So we get familiar with our environment. On the right side of the screen, I'm going to make it a little bigger, probably. Let me go like this, and then. So you see everything is up. This is what we want out of our business, right? Everything is being load balanced between Kubernetes, VMware Pod 1, VMware Pod 2, Hyper-V, and Red Hat. All these consoles are right here, right? So I have one virtual machine that is the web server in Red Hat, another set of virtual machines here in VMware, which are called, well, I really don't remember how I called it. I think it was SCVT, and so many VMs right now. So it's SCVT Web 1. So this is the other one, and then we have one in Hyper-V, as I said, and then we have Docker, right? So I actually opened another web browser just to show you that this load balancer is working, right? So it really depends on your log. You're going to hit one or the other one. So what will happen now? Oh, sorry about that. I get confused with the screens. What will happen now? By the way, I put their Netscaler for now, but my F5 friends got really pissed because they were not there. So I told you can also use F5, by the way, of course. So we just saw that we have an application, and we are running on top of ACI. And for us, again, ACI is just the network better and simpler. We want to add or scale, adding more leaves, more ports, or more APICs, more supervisors, the way we used to see that before. Well, we just need to grow horizontally, right? This is based out, if you're running them on hardware, it's running on Nexus 9000. But remember that you have other flavors like bpod and Cisco Multicloud ACI that you can run without any hardware, right? So with that being said, let's start with the first example. Again, our environment right now is fully functional. Actually, I'm going to ping my web page, and this is fine. This is what the business wants. But imagine all of a sudden something breaks, right? So let's imagine somebody here. This is my APIC environment. By the way, I'm using multi-pod. So as I said, a single APIC or configuration point is showing multiple locations, and you manage everything as if it were a single switch, right? Just for you guys, how many of you have ACI already? Yeah? OK. The rest, are any of you considering ACI? OK, so I'm just going to show this real quick. So basically, you have a single pane of glass, as I said, for all things networking, including all your switches. Whether that's 1, 2, 1,000, it doesn't matter. You're going to get a single point of management, and you don't need to invest in extra licensing for configuring and management or monitoring everything centrally. So here I can just see, for example, what is on the other side of this port 11, which is green. Well, it's connected to an UCS server. It has these VLANs flowing. This is very useful. Remember, by the way, that you can also configure everything centrally. So if today you have configured, for example, your ESX server, right, or your Windows server, they have usually 2 NICs, right? And the thing is that you have to configure a virtual port channel. You go in your Nexus 5K, Nexus 7K, if you have them, and you do VPC peer link, keep alive link. You start, screwing up a little bit, so you have to bounce the port because it went to disable. Here is just a CCS going, I want this port, and say, I want a VPC connection, and I want this to be Windows. And you click submit, and you're done, right? So we're trying to simplify a few of the tasks that you are used to doing, by killing the keyboard every single time. We're used to do that every single time, and we're not getting any smarter by doing the same commands over and over again. But if you consider, let's stop the ping for a second, that we need to increase our IQ by 20 points, we can always have a CLI, right? So just for you guys that are not familiar with ACI, this is just a very brief introductory. If you want CLI, you still have all the leaves and all the spines we saw there managed again as a single switch. So if you want to preserve your CLI knowledge or CLI configuration, you can just say, at the same time, I want to configure leaf 1, leaf 2, leaf 3, leaf 4. And let's say I want to do a no-shot on interface Ethernet 117 to 19. So if you consider what are the difference with the traditional model, every leaf in the traditional model would represent a single switch. You have to do a per switch, per port configuration, per switch, and per port management. Make sense? So just a very small brief. So let's go back to our ping. Again, our business should stay up. And in this case, we also have visibility on the other side of the cable. So today, the thing is that I have all these hypervisors, Red Hat, I have VMware, I have Hyper-V with System Center. And every time there's a problem, the network is the one to blame, right? It doesn't matter if you have visibility into vCenter or Red Hat, it's always the network until you prove the opposite. So one of the things that we think right now is that the network is not anymore on the physical side. You have virtuals, in this case, 1, 2, 3 hypervisors, or even worse, if you go Kubernetes-based or Docker, it's not even the VM admin. it's probably the operating system admin, and you have 3 layers of networking. So why would it be your fault if you're the network admin, right? So we need to make sure we get a better way of understanding what's happening on the other side of the cable, and that's what APIC is trying to do. So in this case, I have direct integrations with Microsoft. If you want to see, for example, in Hyper-V, what's happening inside every server. You can go in here, and instead of asking for permission into the system center environment, you can see, hopefully this will load soon, all the virtual machines that are on the other side of the cable as part of this hypervisor, right? The same part would be obviously with VMware, where we support 3 different flavors. For example, if you have the native DBS, the native integration with VMware, you don't need to do anything with Cisco. All you want is just to get the full inventory and being able to interact with the server guy, so that you can push every VLAN that now we call EPG, right? So you can see everything that is going on the other side, and this is extremely useful for troubleshooting. You now know what's happening on the other end, right? Same thing would be obviously with Red Hat, and we have that integration as well here, right? And also for containers. So in the containers-based environment, the things that we will not see VMs. We will see containers, or in this case with Kubernetes, we will see our pods, right? So again, we don't need to have multiple ways of monitoring and managing the network. The ACI will get you a single pane of glass for any type of network out there. So going back to our high availability scenario. In ACI, we have something called a tenant, which is the basic for every ACI config. Think of this as, imagine today if you have a production and a testing network. Today, you're probably splitting the networks or the subnets. But eventually, testing will become production, right? So the nice part with tenants is that you can split logically all your fabric, and you can even repeat IP addresses if you want. Whenever you want to move from one tenant to the other one, it's totally transparent, and you don't need to do any changes to the addressing, right? So in my case, I have this tenant called SEBT, and obviously that's the name of our company. And if I see the application profile, think of the application profile as a folder of VLANs. Today, you have to go on a per-switch basis to show VLAN and figure out how they are communicating. Right now, the thing is that I have all these E is for EPG, so think of them as your VLANs, and C are for contracts. They are your access control lists, right? So right now, I have a nice graphical representation of all my network connectivity, and in the very bottom, you see, for example, the web servers layers. I have VMware as with a V, M, Microsoft, R, Red Hat, and then K, Kubernetes, right? So that's my application. I don't need you to understand why I built this or how it is there built. But what I need you to see is, imagine again, everything is working, right? All of a sudden, our new admin comes in, and he says, I'm curious. Let's see what happens if I just click on delete and say yes. So this is pretty much not good, right? When that happens, there's problems in the network. I just pretty much trashed every work I did for the last months, and I'm in a problem, right? Because I need my session to continue. So what would you do today to troubleshoot that multi-pod, VMware, Hyper-V, Red Hat, all this complexity? Where do you start? So the nice part with ACI is that you can come here to the admin tab, and the nice thing is that you can take pictures called snapshots at the network level. So you can do this either automatically every Monday, every Tuesday, every Wednesday, or you can do it manually every time you need to. You can do it at the full fabric level or at the tenant level. So I will apply this one that says ACI saved my job, and I will roll back to this configuration where everything was nice and beautiful. I will see that in less than 3 seconds, I should have connectivity again, right? So this is usually something that we try to build, again, because we don't want to be troubleshooting. We want the business back. And in our case, we just recovered a network that was, again, multi-pod, multi-hypervisor, container-based immediately, right? So this is very, very important. Of course, if you want to go to the audit log and see who did it, so that you can go and, hopefully not, but fire him, you can still do so, right? But that's the idea with the high availability part on the network. So if we go back, I keep going back and forth. If we go back here, this is basically what we did, right? We have this concept that I don't really want to elaborate unless somebody wants me to go and click. This is real, by the way. It's running in Miami. It's no flash. This is a real lab, so we can always click on things if you want to, right? But basically what we did is we just deleted the full configuration we had and just recovered it with the rollback functionality, right? In our case, by the way, it's not going to be only the network that it's going to fail, right? You will see after each scenario, by the way, that I will summarize a little bit of what the benefits are for each solution, at least the perceived benefits we have seen. In the case of ACI, as I said, just manage all up to the 206 switches or more if you have multi-site from a single point of management. We will see a little bit of unified fabric. But right now, we cover the 3-second failure recovery and rollback. Okay? Again, it's not only the network that will fail. If something can fail, it will fail, right? So in our case, we have Hyperflex, which is, as you know, our hyperconverged environment. So now let's go to another scenario. Let's imagine right now that we have the NetScaler, as we saw, and we are going to access all these different load balancers. One of these machines is called SCVT Web MPOT1. That's running on the second data center. And what it's doing is that it is running, as I said, on Hyperflex, but at the same time, it's being backed up with our integration through Beam. So if any of these clicks hit the Hyperflex VM, I am constantly backing that up through that native integration. Remember, Hyperflex is an object-based system in the backend. So we are constantly doing snapshots, and we're constantly doing things way more efficiently than if it were a traditional NFS-based system or CFS and so on. So what we're going to do is that we're going to delete a full machine. So this is probably not going to happen that much in real life. We're not going to go and delete machines. But it may happen that your database gets corrupted. So you need to recover it, and you need to recover it fast. How long does it take you to recover something from your traditional, for example, your traditional backup? Minutes, hours, days? So there's some banks that they have to do the full recovery of a full LAN to get to the point where they need it to be. So one of the nice things we have with the Beam integration, and I have it over, so let's just, is that all the, oh, sorry about that. It disconnected me. Is that, as I said, we can continuously use Hyperflex-based, object-based system to continually do the backups through the snapshots, right? So I already have here a few backups. I'm going to go into my vCenter, and I'm going to show you, let's go back to the Citrix. Yeah. So, well, I should have shown you, by the way, when I killed everything, everything went to red. But we're going to do this for this specific example. If you see, we have VMware Pod 2. That's the machine that is constantly being backed up by Hyperflex. So what I will do is go to the vCenter and delete it. So just think of it as a machine that got corrupted and that it's going to be extremely complicated to recover. So we're going to say SCVT Web MPOT 5. And I'm just going to say power off. Yes. And then I'm going to delete it. Delete from disk. Yes. All right, so if everything works well, we should see that we will have a red light, which is obviously not one in here. So we're getting some impact in our operation. We have a few extra servers and a few extra technologies that we can, like have the same time of throughput, but still we're minimizing this by 25% or 20%. So what we can do is I can come back here to Beam and say instant VM recovery. This is one of my favorite features from Beam. So this is, by the way, running on an S3260 server. If you have seen UCS, UCS has blade servers, rack servers, mini servers. There's all sorts of servers. And one of them is the S3260 that allows you to go 600 terabytes in just, I think it's 3 rack units, if I remember well. So basically, I'm saying, please restore it to the original location. Or actually, let's restore it to a different location. Next. We're going to restore it to a Hyperflex node. So right now, I will cover Hyperflex in a second, but I'm running a 4-node configuration. Let's show you that real quick. So everything is being running on Intersite, by the way, in terms of monitoring. So remember, this is a software as a service solution that monitors all your UCS and Hyperflex environments. Oh no, are you serious? I even have turned off my phone. Well, I'm going to show you Intersite in a second then, while this gets turned on. But let's do the recovery, and then we'll go back to Intersite. So I'm going to, as I said, recover this into a Hyperflex node. I can tell it to put it anywhere I want, whether that's a fiber channel target or the Hyperflex target. I will do it on the Hyperflex target. So that's called SCVT Inc. OK. Next. Connect VM, power on, restore. Right? So this should take around 30 seconds. And this is extremely interesting because what we're going to see happening is that if we go back into vCenter, you will see again, there's no SCBT malware endpoint, right? If we see in the lower part of the screen, we see that we deleted and powered off that VM. So it's not there. What should happen now is the S3260 UCS will publish itself as the target. So again, what we want is to recover everything immediately. So we don't want to move or restore every data from the UCS server back to the HyperFlex storage in this case. So you will see that what we will see in a minute or a second, let me refresh. Okay. So you will see very soon that it will say registering VM. There you go. So it's registering directly again from the UCS S3260. So it's not doing the migration fully for you because that will take days or hours, or it's just publishing it so that you can use it, and then we can do the migration as a background process, right? So let's hope this came back to life. Let's see where it is. Here it is. So it's still turning on. So let's wait for it to boot up. There you go. There it is. So we're ready. Let's see if sometimes I need to connect it manually. Connect. There you go. OK. So hopefully that red light will go back to green. There you go. Right? So again, the idea for us is if you have a network problem, fix it as quick as possible through snapshots or rollbacks and so on. But also, the hyperconvergency piece plays a very, very important role of it. So far, so good? Any questions? OK. So we're going to keep going then. Let me see if I can now log into Intersite so that we can see that this is effectively running here. Yeah, that's a problem with security and two-factor authentication. OK, it's coming up. There you go. All right. So as we said, in the part of Intersite that I wanted to show you, we have a single dashboard. I have here multiple accounts. You can have multiple data centers or multiple accounts. And in my case, I have the servers in the rack servers, the blade servers, and so on, directly connected over here. So you will see that from here we can come into the HyperFlex clusters, and we can launch our HyperFlex Connect directly from here with single sign-on, right? So as I said, one of the things in HyperFlex is that not only do you have this fiber channel integration so that you can storage remotion between them, but you can combine converged and compute-only nodes. So remember, you can grow them independently, right? So again, this is our environment. And so that you believe me, we have, on the data source, we should have this SCBT Inc. Data store where we put our VM, right? So, and it's mounted on all 4 nodes, all right? Well, let's then go back. As I said, once you're done, what you can do is say finish, and then go into instant recovery, and say, oh, now I want to migrate to production, right? So it will do that migration for you to the path where you specified it, in this case, the SCBT Inc. LUN, or data store, and you don't need to do anything else with that. So I'll just leave it there running so that this gets fully restored. All right, finish. So moving on. What could happen as well is that, of course, we have this single pane of management, not only for ACI with ACI and the APIC, but Intersite is our single pane of glass for all things, including hyperconvergency. So remember, UCS is an architecture. It has blade servers, rack servers, mini servers, artificial intelligence servers, storage servers, and hyperconverged, right? So for us, the idea is to be able to scale, as we said, from small to large, but still add more and more resources. And then there's some applications on top of it, like CCP, right? So for example, if you wanted to run Kubernetes or OpenShift, and you don't want to deal with the installation of Kubernetes or an OpenShift, you can still install that, and that will be automated for you, right? And that can run on top of HyperFlex. So today we run CCP with VMware, although we're also running it or starting to run it on KVM and bare metal directly for containers, right? All right, so we did that. Less than 15 minutes in recovery time objective with Beam, and obviously Commvault. I cannot be unfair to those guys. So we do also have integration with them. But then there may be more changes in high availability. I live in Miami, so we are hurricane prone. Every single time there's rain, and actually I'm still crossing my fingers that nothing happens there because I don't have a UPS, right? So hopefully everything is good, but this company is growing, and hurricanes will make me try to extend this now in different locations, probably San Jose and Miami. So we have, in ACI, we have this other technology, we covered multi-pod already, called multi-site. Basically, multi-site is if you don't have less than 50 milliseconds in round trip time, or you cannot comply with multicast and jumbo frames, which is what multi-pod requires, we have this other technology that you can give us a routed network. As long as you have one APIC fabric, just give us any routed network that is less than 1 millisecond in round trip time with a third element called the multi-site orchestrator. And we will extend that layer 2 for you automatically with VXLAN. The nice part with this, compared to multi-pod, if you remember, multi-pod is just a single switch, right? If we go back into our original environment with multi-pod, we remember that if we do any change here, if we create any VLAN, everything will be pushed simultaneously. So there are some customers that tell me, well, what happens if I screw up, if I make a mistake? Well, basically, you're going to make a mistake everywhere, right? So, and you're protected by checkpoints and rollbacks, but still. So one of our customers that has 12 data centers with ACI, a service provider, they told us it would be great to phase out those changes, to see that everything is green on one side and then push them to the secondary side. So that's what we're going to do now with multi-site orchestrator. We have 2 separate fabrics, totally independent. If I didn't have multi-site, I will need to go and configure one first and then configure the other one. Multi-site orchestrator is a set of VMs that as long as they have reachability to APIC, you can place them anywhere in the world. And from there, we will be able to automate the layer 2 extension and provision our policy centrally. So that's exactly what we will do right now. We are not as restrictive. In this case, we don't need multicast. Even we can get away without jumbo frames, by the way. But it's always recommended to have it. All right, so this is what we're going to do. I'm going to show you that we have now, since we grew, we're going to have a different setup now using multi-site, and we will compare them both. So I have on the left side, I have Miami. On the right side, I have San Jose. We're going to be extending a layer 2 interconnect to do long-distance vMotion. So this is something that most of our customers ask. I want to make sure it's a single network. It doesn't matter if I have 2 or 12 locations. I want to make sure I can move back and forth, because probably the data center redundancy needs to be active-active, right? So this is what we're going to be showing. ACI now also covers or allows you to do fiber channel. So in my case, I have UCS servers with fiber channel connections, or fiber channel over Ethernet connections downstream, although they could be fiber channel. And then I have that connected to MDSs, so that's the storage replication, if you will, so that we have the same storage on both sides. And then through multi-site orchestrator, we will do a real-time configuration on the extension of layer 2, right? So this is what we're going to do right now. So first, let's go and see. This is a different installation, so you will see first our APICs. It's a set of 2 different ones, 1 and 2. And then we have our multi-site orchestrator, which I will cover in a second. And then you have 2 different data centers. So we have data center 1 in the low end and the lower part, and data center 2 in the upper part. So that's vCenter in link mode, right? So let's try to do a vMotion right now between each of them so that we see that there's no working configuration for layer 2 extension. I have here a machine that is called vMotion test VM. So I will say migrate. Next. I will migrate from cluster 2 to cluster 1, in this case. And it should tell me an error. It tells me that 1, it doesn't have a VM kernel adapter, and 2, obviously we don't have layer 2 interconnect. So that's exactly what we will create. And if you remember the video I showed at the very beginning, this would normally make you have MPLS or Ethernet over MPLS services, or dark fibers, or extend the layer 2 network somehow by paying the service provider. So we will see how hard it is to configure this. So again, we have one ACI fabric here. This is site 1, Miami. And then we have site 2. They are totally independent, but they are linked. If you see there's a little cloud here at the top, they are linked and configured by multi-site. So I will provide, first, I will show you what multi-site is. So from here, we can see the health scores for both sites, Miami and in this case, San Jose, right? If you see one of the things we can do here as well is we can also configure checkpoints and rollbacks, locally from here, even if it's multi-site, right? So just for you to know, that's there as well. But then if I go back to the apex, you will see that in the tenant layer, or tab, I just have two tenants, my SCBT Inc. and my Unified Fabric tenants. The Unified Fabric tenant is to allow the SAN connectivity that we explained before through ACI, and the SCBT Inc. is the one that has my application, but now will be distributed between both data centers, okay? So let's create then a third tenant from multi-site and see how we can stretch that layer 2 connectivity. We will call this vMotion or Stretch Fabric or whatever you want. So, as I said, there's nothing right now that tells me that configuration exists. So let's do it from multi-site. So the first thing I need to do is go here into tenants, and I will say add tenant. Let's put this Cisco Live as a tenant. And I can say where I want to push this configuration to. Here's two sites, so I want to push it directly to both at the same time. I can say save, right? So if you see here, that Cisco Live tenant is already created, one tenant and one site, as well as on the other one, right? All right, so let's go back. The second step that we would need to do is provision that layer 2 extension, and we will need to provision a VLAN, which is called an EPG, to make sure that VM kernel connection is extended throughout both data centers, right? That's something we call schemas. So the schema is that, like the recipe, if you will, for that network configuration. In our case, we will add a schema. We will name it DRP, or active-active, active-active. And then we will say that my template is going to be stretched network. All right, so first it asks me, which tenant do you want to create this stretched network for, or this template for? Well, I want to create it for Cisco Live. This is my tenant. Second, what is the name of your application profile? That's the folder, right? So we will say this is long distance vMotion. And then last, I will need to add an EPG. The EPG is going to be called VM kernel, because that is the type of network that we will need to extend vMotion, right? You need something else called a bridge domain, VM kernel bridge domain, which is basically your subnet, if you will. So we're just going to create it, right? And obviously a BRF, which we will create as well here. Now, BRF. All right. That should be it, right? So let's do save. We already have the recipe. Now, what's missing then? Well, we need to add sites. We have the general recipe, but we haven't said where we want to push it and using what type of infrastructure locally. So I'm going to say I want to add it to both sites, site 1 and site 2. And then you will see that there's this exclamation mark. Why does it tell me that? Because remember, an EPG can be pushed to VMware, Red Hat, Hyper-V, OpenStack, bare metal, and so on. So locally, each data center may have different vCenters, and they may be named differently. So I will need to specify where this is going to be pushed on each site. On site 1, I will say that I want to make this available to a BMM type of domain on a DBS switch, which is VMware's default switch. I want to do it immediate. And then I can add, just for the sake of it, I can add a specific VLAN. In my case, I think it's VLAN 601 if I remember well. So let's do save. And I will do exactly the same thing for site 2. So far, so good? Are you following me? Yep. So again, VMware, DBS, immediate, and then we will say, static VLAN 601. All right, so we should be good. Let's now do the deploy to sites. So what multi-site will tell me is it will tell me on both sites I'm going to configure what you just told me. An application profile called long distance vMotion, a BRF called VM kernel BRF, a bridge domain VM kernel BD, and I will associate this with the EPG. Remember, since we already associated to VMware, after we say yes, deploy, ACI will talk to vCenter on each site and present this network so that it is available for us to configure a vMotion adapter. Okay? All right, so let's say deploy. We should see, if everything is okay, we should see that we must have done some changes in the vCenter. So if you see here, it says add 2 distributed virtual groups, right? So those are exactly what came from multi-site. So let's now, I'm going to create a VM kernel adapter. So let's configure. I'm just going to create a VM kernel adapter. And I'm trying to do this in real time so that you guys see the full thing working. But if we browse the network, you should see that we already have this available, the one that we created from multi-site. And I can say, next, IPv4, this is going to be used for vMotion. And I can do static settings. In my case, I'm going to do 61.70. 55.0. I think it's 601. Let me just double check because sometimes I just forget it. All right, pools, VLAN, multi-site pool. I have already a predefined multi-site VLAN so that we can use that for. Oh no, but this is not it. Oh, it's 601, perfect. So again, going back, 601.77, okay, and then next, and finish. So that's one, and I'm gonna just do it for 2 servers in this case. Let's see where this machine is, by the way. I don't remember if it's 77 or 78. Oh, this machine is living on 78, my bad. So I'm gonna create a VM kernel adapter as well there. Next, select the same existing network, okay, next. I'm going to say this is for vMotion. Going to use an IP just like I did before, 61.78. So it is coming from the multi-site orchestrator. So if you remember, every time if we go back here, let's see site 1, right? This configuration got automatically pushed from multi-site, correct? If you see, actually, this says this has been created for multi-site. So if you do any changes, we recommend you to do it over there because we will always try to check consistency, right? If we go here into the application profile, you see everything that was done with multi-site will have a cloud, a little cloud, right? And we should have the topology that says you have a VLAN or EPG, and that was pushed already to VMware, to vCenter. So again, what multi-site did is when you said site 1 and site 2, it created consistently on both sides the same EPG and pushed it locally to its own vCenter. So vCenter now has that port group available to assign to anything you would want. In our case, we're assigning every time we create a VM kernel adapter, just like we're going to do right now. So when we do add networking, and we say select an existing network, it's because we are assuming multi-site already pushed that network from the automated process. And you can see it right here, right? So you can see it. You can see that it says Cisco Live is our tenant, long distance vMotion, our application profile, VM kernel, our EPG. Make sense? So that got pushed directly from there. We don't need to do more. So I'll do this, okay. Next, and this is the last IP I will do. So 192.168.61.73. All right, next, and finish. So let's try that again. Let's give it another try. So I'm going to try to do vMotion from data center 2 to data center 1 on my server 1. I see now that all the compatibility checks were succeeding. I see that we don't need to change anything. Everything is next, 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 finish. And now I'm doing a vMotion between both sides, right? So again, this is just making sure we extend both sides together, just as if there was a direct fiber, right? But we're not having to pay anything. Just give me any layer 3 routed connection, and as long as we have that, we can create a tunnel for you with VXLAN, and that's it, right? Any questions so far? Good? All right. Well, let's then move on to the next scenario. Love like demos. All right, let's give it another try. Know if there's a network problem between both sides, but in the end, this should always work. Don't know what I did wrong, but anyways, I hope you believe me. By the way, every demo I do is recorded. If you remember, there's a YouTube channel. that I showed at the very beginning where the video was. So every demo I do is recorded here, and it's part of at the very end of the slides, you will see that there's a link to it. So if you want to see everything slowly at your own pace and all that, it's going to be there, okay? There you go. Okay, now, oh, actually it's not this one. There's some error. Don't really know why this may be. Let's try a different server. I hate when a demo does not work the way it should, but everything is working in the configuration level. It's just that it seems that there's something going wrong between both sides. So let me just try with a different server real quick. 61, that's 74. 0, next, finish. Okay, so let's try to move that to the other server, and let's hope it works. If not, I hope you believe me. Next, 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 finish. It's getting stuck at 37%. But this is not a layer 2 problem. It's probably something different in the routed network. Well, anyways, I mean, it works. I'm sorry if it will give me that failure. So, going back, and this is very important, by the way, because if I don't provision the layer, you will see actually the layer 2 configuration extension in the other tenant I already have provisioned. Yeah, there's some timeouts there. I don't know if there's something in the middle of the network, hopefully not. Okay, so this is, as I said, something that is very, very useful, because you can stretch any bridge domain, or you can just leave it on a stretch, on a per tenant basis. The other part I wanted to show you, we already covered a little bit of the integrated data center interconnect, the multiple switches managed as one. So if I have time at the very end, I will try to fix that in case you guys want to see it working. So yeah, so the latency we have to fulfill is 1 second between the multi-site orchestrator, which is the VM, and the APIX. And that's the advantage. If you remember, multi-pod was 50 milliseconds or less. Why? Because it's a single switch stretch through different locations. But in the case of multi-site, this is a single VM or set of VMs, in the case of the multi-site orchestrator, that has nothing to do with the data plane, that has nothing to do with the local fabric. So we're just pushing changes centrally, right? That's why it's 1 millisecond. And it does not need to be even on an ACI site, by the way. It can be anywhere, okay? All right, so again, I'm not happy with that. I'm going to try to fix it at the very end, and I'm going to see what's happening. So seamless growth. This is also very, very interesting. So let's go to the second use case. Second use case is we have to grow, and we will grow eventually. But you don't want to pay for this massive switch at the very beginning like before. It's like the Superdomes back then. Everyone would buy Superdomes, but today there's nobody that would buy that. So we need to scale out as our businesses grow. And there's something called remote leaf that we will see now with ACI. So basically, let's imagine that we acquire another company, and then we have an ACI fabric. We have a routed network in the middle. So if we have a satellite data center, a brownfield, or a telco or co-location, instead of building the full ACI fabric with APIX, spines, and leaves, which would probably mean a big investment, you can just send somebody with a pair of brand new remote leaves, and that way, as long as you have routed connectivity in the middle between your main ACI site and that remote location, you will be able to extend that layer 2 as well and manage everything centrally. Right? So it doesn't matter if your guy will go there and does not know anything about networks, and this is what we will do. We can just power on that equipment, and as long as we have routed connectivity in the middle and DHCP relay all the way back to the ACI center, that's all we need, okay? So again, this is very, very useful if you today have 2 data centers and you cannot migrate them both to ACI at the same time. You might have Nexus 5K, Nexus 7K, and you want still that layer 2 extension. You can just put a pair of remote leaves at the other end and hang everything from there, right? Or as I said, some sort of co-location or anything you may need. So in this case, these are the requirements as well, 300 milliseconds in round trip time. We don't need to do any multicast or any of that. And this is, as I said, zero touch. So how do we do that? Well, let's go back to our first scenario, multipod, right? In multipod, we have, at the moment, 2 spines, 2 leaves, and 1 APIC. But let's assume we already sent that guy, the one that has the physical leaf, to the remote location, to that new company we just acquired, because we need to integrate it to our network. So basically what we will do is we will tell them, go to that office and please connect, in that banking corporation or whatever, please connect the new Nexus 9000 on interface 152, and I will do the rest of it. Turn it on, and I'll do the rest from here. So what the remote leaf will do is it will send, when it gets booted up, it will send a DHCP address request. Through IP DHCP relay, we will reach the APIC, and then I don't know if you have seen how you add new switches, but it's just 3 clicks. Every time you discover a new switch, you do 3 things. 1, assign an ID. 2, put a name to it. And 3, say OK. And ACI will take care of the rest. It will build automatically, in this case, OSPF, which is my underlay protocol. And then it will build on top of that VXLAN, right? So that's what we will do. So if we go back, as I said, there are no remote leaves right now, right? We only see 2 spines, 2 leaves, 1 AP controller. All we need to do is go back to the quick start, and we can say set up a remote leaf. The first thing we will need to say is which pod do you want this remote leaf to belong to? I want it to pod 2. Why do we need to do that? Because it's a leaf, and remember the leaves sometimes may need spine functionality. Remember ACI, every time you connect something, it gets registered to the fabric. So you know every single IP, where it is connected to, what tenant is using it. So with that being said, if for whatever reason you don't see it locally on the leaf at the MAC address table, if you will, it will, for those of you that have been with Cisco long enough, it will punt it, if you will, to the proxy. In this case, the proxy is the spine, right? OK, so that's what we will do right now. We will say, I want you to belong to pod 2. And then you will take an IP address from this pool that I already have created. That means if you get a request, and it's a remote leaf, I will send you an IP address automatically with one of these subnets, right? OK, so let's say next. I say I already have discovered a remote leaf. So again, 3 clicks. 1, node, in this case, my node ID will be 121. And let's say this will be remote leaf 121. OK, that's the 3 clicks. And then the last part is you need to configure the underlay. If you remember, ACI on the main site has ISIS as the underlying protocol, right? You don't get to configure any of that. But here, in the remote leaf, you don't know what you configure on the other side. And in our case, we're using OSPF. We have a router on the other and the branch office. I want to connect that leaf using OSPF so that on top of that we create VXLAN. So I have to tell ACI that once it sees that switch, that leaf, that it creates an OSPF for my remote leaf configuration. And probably in the other end, I already have my router, which is working on regular area 0. And I can say which interface is the one that I'm connecting to. Where did this name came from, by the way? Do you remember at the very beginning when I did the BPC configuration that I said this port and this port has the Windows name, right? So back then, I did something similar for this physical routed domain, and I put a name that is now OSPF remote leaf, right? OK. So route IDs. What is going to be the node where I want to configure OSPF? 121. What is the router ID I want? I can do whatever I want. 121, 121. Let's do it this way. Update. And then I'll say, go, whenever you detect node 121, on interface 152, which is where I connected to my router locally on that branch office, I want you to go ahead and configure an IP address that was, what was the IP address I had configured? I think it was 192 something. Yeah, there you go, 172.16.12.1/24. All right, finish. So what should happen now is that we will see all the elements on this fabric, right? And then you see that 121 remote leaf. It has a 0000 IP address, OK? So it's still waiting for the IP DHCP request to come in. Once it comes in, that IP address should change into something with that pool that was 192.170, if I remember well. So if you see, now it changed to discovering. And hopefully, it will display the IP address soon. It usually takes around a minute or so. But again, the idea for us is not to move to that remote location and configure everything locally, but to do everything centrally. So let's wait a little bit more. By the way, while this happens, I have in the middle, between that remote location and the central location, as I said, I have a routed configuration. And the only thing you need to take into consideration is the first hop from the spine to the first IPN hop is configured with OSPF. Why is it OSPF? Because that's the way the wizard is configured to run on, right? So just something for your information. So hopefully you see now that we have now a 192.170 IP address assigned to it. It was 00 before. Now it already assigned an IP address. And we should see that it will become active very soon, right? So taking a little longer than usual. But again, this is way faster than me going to that remote location and configuring that switch and putting an IP address to it and configure all the things I would need to do. So let's hope it gets active soon enough. Still discovering. Every time you're presenting, sometimes it feels forever, the clicks, like it's taking way longer than what you usually see. There you go, it's there. So if we go back into the topology, you now see that we have 2 leaves and 1 remote leaf. And if we view the pod, if we view internally that pod, you should see that there's a remote leaf hanging on from the one and using the spine functionalities from the main pod. Okay, good? Yep. All right, so from there, again, if you want to start configuring a specific port, you can come in here into configuration mode, add that remote leaf 121, and we should see that switch is ready for us to do something, layer 2, layer 3, whatever, all right? Okay, so that's the remote leaf part. What could happen is when we integrate that new data center, it could happen that there's something wrong or something weird happening in that location. Probably there's a duplicate IP address. Probably I have some sort of issues I need to fix. So this is just a commercial, by the way. You could do the same. You could do the same with HyperFlex Edge. I'm not going to do the full installation for HyperFlex Edge because it would take us 30 minutes, but that's as well on YouTube. So this demo is on YouTube, and you could do exactly the same thing, connecting a HyperFlex Edge node directly into that remote leaf, and you have a full branch solution, right? That you can manage centrally. Anyway. That's good for the commercial, but network assurance, again, you could have some problems once you integrate that element, right? So maybe there's an overlapping in IP. Or how many times have you had a problem that you create an access control list, and then probably nobody wants to touch it, right? It has been there forever, for years and years. And the new guy comes in and he says, well, it's a 1,000 line long, but I'm not going to be the one to blame if something fails, right? So all of a sudden, you have this huge configuration, and you don't really know, 1, if you're following the best practice, or 2, probably there's a permit any at the very top of it, and then 1,000 lines denying traffic. So it doesn't make any sense. But the switch will take the configuration, right? So instead of you having to hire somebody to tell you if the configuration is correct or not, what you can do is use this thing called network assurance. So network assurance is, now if we move to, you remember the very first slide, right? If we move to the top part where we said analytics, in the assurance part, this checks for the correction of, or the correctness of your configurations. And it will also give you best practices, as well as probably detect any potential issues you may have. So in my case, for example, I have linked this to my ACI fabric. And we have several things that this is reporting constantly. One of them is a duplicate IP, right? So I have the IP, I think it was 1112 that I purposely duplicated. So you can see where that IP is being duplicated at and how or what you need to do to fix it. Obviously, in this case, it's very easy, right? But there's other things that may not be that easy. For example, this thing called access entity profile, which is a specific ACI construct. There's so many times that we're learning how to use some things that we just leave a configuration there. And it's not being used by anything or anyone, but it's still there. And it's potentially going to complicate things whenever I troubleshoot. So if you're not using something, it will tell you, you know what? This thing is not bound to anything. You can confidently remove it and know the impact of change before you actually do it. So again, this is a very, very powerful solution because it will tell you what the best practices are. It has 5,000 plus built-in scenarios. And then you can also see if you're starting to get some access control list or contracts in the world of ACI that may affect your TCAM usage, you can monitor this here and you can probably optimize it as well. I don't have any large TCAM usage so far. But the other part is also maybe for compliance and security. You want to quickly see in the multi-tenant environment what is being talking to what and how. So in this case, I have in my configuration with ACI where I can very quickly see, the database servers are talking to the web servers only with ping and web. At least that's the name of the contract, but it says other things, by the way. It says SSH2. So if you want to provide audit capabilities to your security folks and make sure everything is consistent, you can use network assurance as well. That makes sense? Yep. All right. So this is, by the way, as I said, VM only, right? Everything I'm going to talk about in the analytics layer is software only, with exception of titration that can be software plus hardware, right? All right. So that's exactly what we just did. So again, NAE, it includes ACI, but it's not only limited to ACI. We're opening more and more assurance to other brands and other functions. And it takes less than 30 minutes to deploy and less than 10 minutes to identify potential issues. So even if you have an ACI environment, it would be very, very good for you just to run the demo and just for the sake of it knowing if there's something that you can potentially get better. I didn't say this, but again, you don't need to pay the account manager initially, at least, right, if you want to see this. Then there's a subscription called Premier, ACI Premier, just as Essentials and Advantage, that includes this. So it's a very small delta, and I think it's the best practice to always have it on. But again. The other thing, security and compliance. So this is something that we definitely need to take into consideration in every single project. We cannot protect what we cannot see. And the problem is that most of the times we don't see many things happening in our environment. So here I have different views of things, of the strategy that we will take as a CBT Inc. One is we need to see everything. 2, we need to reduce the attack surface. And 3, we need to do threat protection. We need to stop the breaches as soon as possible, or as soon as they happen. So in my scenario, I have titration, but just wanted to make sure that you're aware that if you have a StealthWatch, you can also cross or correlate titration through StealthWatch and vice versa. One of the things that we also use sometimes is Cognitive. So Cognitive will get all these flows that you have, and it will correlate if this is a well-known pattern that may be malicious to you. So again, based on Talos, our intelligence group, it will say, hey, you know what, this looks like Configure or Keto or malware or whatever, and it will tell you that, right? So in my case, let's start by showing titration. So this is the main dashboard. Titration, as I said, can be a platform that runs either on hardware as a set of virtual machines, or even as a service, so you can choose whatever you may want. And this is a historical database. Basically, it will capture every single flow that happens in your environment, either through software sensors, which is something that we recommend, because that's totally agnostic to anything, right? So for example, if you have a Linux, a Windows machine, containers, and so on, if you have that software sensor, you can export every single flow back to this platform and analyze it for you, right? The nice thing is that you will see things like processes also, and you can check the health for those processes. Or you can also do network sensors. Nexus 9000 has this capability of exporting every single thing to that titration platform. The problem is that at the network, you don't see the processes, right? So again, probably the second recommendation is to go with network whenever you cannot use it at the sensor level. Or if you have the traditional ER-span, NetFlow, and so on, you can still get away with that. But again, it's not that recommended because you're not seeing everything. You're sampling with NetFlow, or you're sampling with ER-span. But still, again, this is the outcome of it. However you feed information into titration, titration would analyze it in different fronts. For example, here, if I check vulnerability score, I have 0. This is horrible. So let's see why. So in my case, it seems that titration detected that there are several vulnerabilities in this specific endpoint that is probably not helping a lot in terms of security. So I could potentially get hacked on any of this. What this is doing is basically communicating with something called Talos. So this is our main security group, and basically every vulnerability we report is here, right? And it has a CVE ID. So what titration is doing in this case, it's comparing everything that it's capturing and making sure if there's a vulnerability associated to that operating system or that service pack, for example, so that you have that full database in real time, right? So the other thing we also check is the process hash. So in the process hash, this one is okay. Let's see if I have one that has some, yeah. For example, here, it checks the file reputation inside the operating system. So for example, again, if you have some files that may be malicious, we want to make sure that you are protected. So in our case, we do check the hash score, for example, this one, and instead of you having to go to Talos and go into file reputation and copy and paste the hash, we do that for you, right? In this case, it should say something, right? But that's the idea with tetration, that you get that full visibility into one, as I said, the vulnerability score, second, process hash, third, attack surface. And this is where it starts getting interesting as well. I have my application, which is based on a web server-based environment. So just out of the box, and by capturing every single flow that happens through your sensors, tetration will tell me which are the layers my applications are using. For example, here, it's telling me that I first hit, through the internet, the layer of web servers. And it is building automatically, according to the processes or the ports it's receiving on, every server, and it's classifying it into a cluster that we call it. That's the web servers cluster, by the way. So you don't need to do anything, because this is already, in this case, with very high confidence, it's knowing that these are part of the web servers layer, okay? So again, this is very, very useful, because you don't need to map everything that happens in your business little by little based on the layers of your applications. Of course, there's some times that it will not know what it is, right? But if you tell him once, it will do machine learning afterwards, right? So what information did you get out of this application view? Well, basically first, the nodes. Second thing, the ports it provides and the ports it consumes. So this is extremely interesting because, again, today you're opening 65,535 ports per server. And you may only need a handful, but you don't know which ones. So the nice part with this is you have that information. If, with that information, you want to do something, you have 3 different ways of doing it. Whether you export it through XML, YAML, or JSON. The second part, you can use applications, like for example, if you have ACI, you can push this application directly into tetration so that the network enforces everything. Or the third one, you can use it with your firewalls. If you have an ASA firewall, a Checkpoint, or Palo Alto, and I hope there's no Cisco security guys because they are going to kill me. But if you have any third-party firewall, you can still integrate with that, okay? All right, so how does it do it? So basically, it checks all the conversations that you have, and then it builds, or it suggests you to build policies based on those conversations, right? So if you agree, this is what you would need to use and permit only. The rest of it should not be allowed. This is not enforcing anything yet. It's just telling you that it would be nice. So in our case, we have a server that has a malware, right? So if I do inventory search, there's this server with this IP. As you can see, you can capture several things from the filters. You can do annotation-based search. You can do a network latency, application latency. You can see pretty much many things. But here, I have a software sensor. You can see, one, the processes that are running inside my server. So for example, in this case, I have a virus called configure. So I can see every single process that is running, and I'm highlighting the ones that I know this virus is affecting, right? But as I said, you have all the visibility into the processes that are being running inside the host. Also, the long-lived processes, and this is where all this hashes information is being taken from. But the nice part of this is that I already know this is compromised. The sensor can not only be a reporting solution, it can also be an enforcement player, right? So for example, right now, I am permitting everything in and out of that operating system at the host level, right? So we're not doing any microsegmentation. If you think about microsegmentation, the concept is go as close as possible to the application, right? And as of before, we used to do that as the hypervisor layer. But today we can go even further. We can do microsegmentation through tetration sensors on any cloud, any hardware, any operating system pretty much, basically Red Hat and Windows, right? Or I mean Linux and Windows. So what we're going to do here is I already know there's something wrong here. So what I did is I quarantined that specific host, right? So we're going to see how that tag will play a role in our microsegmentation strategy. Right now, if I go back into my vCenter, you will see I have this machine called SEBT malware mpod, which is the one that is infected with service host, right? So let me show you that this should have internet access. What do you want to see? FIFA. Let's see how the Barcelona game did yesterday. So we have a good internet access. We're infecting everyone. That's perfect. We have malware and we don't know. But in the end, again, there's connectivity right now. So we will tell tetration to protect this machine, right? Based on what? We already have the criteria it gave us if we go back into the policies, if you remember, we have the criteria it gave us based on what it saw, in terms of what's talking to what. But this is including the malware conversation, and you want to stop that, correct? So what we could do is, on top of that policy set, we could create some absolute policies. What I'm going to say is, if you see titration, anything with the tag quarantine on it, I don't want you to talk to the internet, okay? But that's probably not very descriptive, because in the end, we may have, in this case, Configure is the virus I have. It affects every Windows and Explorer combination. So imagine how many servers out there may have the same vulnerability. So what I can tell also to titration is, anything that may be vulnerable to this specific CVE ID that I got reported from the titration database, I also want you to block it from internet. So it doesn't matter if tomorrow you connect 100 more servers with Windows and Explorer, it will make sure that they are not accessing the internet because they are potentially vulnerable. Make sense? Yep. So what is separating us from doing all these policies? Well, we have to go here into enforcement and say enforce policies, accept and enforce. So what will this do? Well, basically, again, based on the conversations that we had read, we created a set of policies assuming all those conversations were good. So we're first going to enforce the absolute policies, right? We're going to do quarantine does not talk to internet, which includes our host. Anything vulnerable through this CVE will not talk to the internet, and then we will allow the rest. Then we will go to the next layer, which is the default policies, and we will execute all of this, assuming that that traffic is healthy. And the last part, we will deny everything else. Make sense? So again, the software sensor is not only reporting me, but it's also enforcing all this at the microsegmented level. So let's see where I left that malware pot. This usually takes a few seconds. By the way, you may be asking yourself, how does this work? Well, we're importing into Windows and Linux firewalls these rules, right? So the sensor is interpreting those instructions from titration, and it's executing those firewall rules locally on the operating system, right? So let's try to test it. Let's go now to NFL.com. So hopefully that will time out eventually. And again, it is because we just blocked that specific malware host, right? So let's see if it times out. Almost, hopefully there. That's exactly what we wanted, right? So if we go back into titration and we say, well, everything is just good now, let's just for whatever reason stop the policy enforcement, we can go back and we should have connectivity again, right? So again, this is very, very useful, not only because you're reporting vulnerabilities, because you're reporting hash or file reputation, you're reducing your attack surface, but you can also do all types of visibility into it, right? You can filter, as I said, if you want, for example, let's say in your flow search, you can search for network latency, for example. If there's a problem in the network latency or if there's a bottleneck, you can always filter based on several attributes of many things, right? So this is extremely important. So if we go back, hopefully we will have connectivity again to NFL.com. This usually takes a little while because it's removing all this access lists locally, right? But so far so good. Yes, you do. Again, that's one option, right? And that's the preferred option. If you go with that agent, we have full visibility into everything that is happening inside the operating system. If you don't, if you for whatever reason cannot install an agent, we can still get away with networking information. So the switch can capture everything and send it to the engine or ERSpan and NetFlow. So it's actually a question that comes in very much all the time. Basically, it's 30. So we have 30% of a single core is usually what we would take. We can limit. This is taking longer, but it will work. There it is. We can basically limit the quota of the CPU that every agent takes. So for example, we have some customers that are media server based, and they will probably send a lot of information, and we want to make sure that it never surpasses that amount of CPU. So every agent is, by the way, configured, downloadable, and installed directly from here. So if you see here, there's let me actually come here. Here's all the agents that you can directly install from here, right? And the software agent configuration usually has a quota mode, right? So if you see here, the default is 3%. We cannot go more than that. You can adjust it if you want to, but we will never go more than that. And the same with the bandwidth. Bandwidth is very minimum. So we don't do lots of things because we're not copying the payload, by the way. Yeah. So it weighs in. It weighs in based on different configurable patterns, but you can also, execute it in the order you desire. So you can always mix it. And this also takes into consideration dynamic ports, which is very important because some applications may change. So if you are starting to run ADM, application dependency mapping runs, that's what we call it, and it detects a change in the port and it sees it's a Microsoft application, for example, it will adjust that dynamic configuration. So then the other thing, well, as part of the story, by the way, and I forgot about my story over here, is basically we did the segmentation on titration. But again, what could happen is that you may not be able to install a sensor, right? Or you may need to do network microsegmentation. And I don't really like the term network microsegmentation, but let's just say that you want not to do a switchboard mode access, VLAN, whatever, or in the case of ACI, assign endpoints to their EPGs. You want to do this dynamically. So in this case, I have an example. For example, imagine that you need to isolate every CentOS VM out of your system because you know that there's this ransomware that is only affecting CentOS. And you don't know or you don't have every agent locally on every CentOS because that's exactly what you're trying to prevent, right? So what you can do, and I'll do this real quick, is imagine you have, as I said, 1,000 machines over there with the mortal combination is in this case of CentOS. I think I should have it here. And it should be, communicating with everyone. So let's try to ping something from here. There you go. So again, this is a CentOS-based machine, has connectivity, but it doesn't have a titration sensor. So how can you leverage ACI then? How could you play a little bit in favor with network microsegmentation? Well, I can go into ACI. If you remember, everything starts with the tenant at my application profile, and I can say I want to create a microsegmented EPG. This is just like a dynamic EPG. I can say, ACI, I want you to go and search for every CentOS machine that exists on a specific network, right? So, okay, submit. What you can do with this is you created the EPG or the VLAN. You can say which attributes you want ACI to look for. So for example, if I go here into my EPG, you will see that there's this concept of attribute assignment, microsegmented attributes. And then we can say, ACI, go ahead and look for a specific IP or a specific subnet or a specific MAC address or a specific operating system, as I said. So instead of you assigning an endpoint to a VLAN, just as we are used to doing, we can just tell ACI, go and do it for me, right? So in our case, again, we want to have if the operating system equals CentOS, we want to make sure ACI automatically assigns it to this group or this EPG called no CentOS. And if you see, this is totally isolated. It does not have any contract, so it will not be talking to anything. If we go back, the machine still has connectivity. So what's missing, right? Well, basically, ACI, as I said, can do microsegmentation on VMware, Hyper-V, Red Hat, and so on. So we just need to tell ACI, go and look for this attribute or this type of machines, in this case in VMware. So I'll do exactly that. I'll say close and submit. So hopefully, actually don't know if this is the network I should. Hopefully this, I thought this was the machine that was there. Oh, there, no. Wait a sec. My bad. Let me see, no CentOS. I don't really know if I chose the right subnet. Okay. Oh, I see. I am pinging the wrong machines. Oh no, man, I screwed up. So, well, I am pinging the machine that is actually not part of that EPG. I should be pinging another one. Oh, damn it. Well, the thing is that due to time, I think I won't have time to repeat it. But basically, it's just a dynamic assignation. So if you see here, one of the things I wanted you to see is that this machine called SCVTDV Linux, which is the one I just assigned, it got dynamically assigned to this new group, right? Again, I chose the bad IP. I really don't know which one is in another group. So let's try to get into probably ping 222.33. Yeah, this was the other network I needed to show before working and then not working. Oh man, I'm sorry I got confused about that. So many things going on in my mind right now. But the idea for us, again, is to dynamically segment and assign any endpoint into any EPG, right? Again, if it does not have a contract, it will be isolated. But I just put that example based on security, but it may be applying to production, to testing. If you tag anything, then they automatically get assigned to the right VLAN. So that's the concept. More than the security and permitter deny or whatever, I just want to show you that there's a dynamic association of any endpoint due to attributes like tags or names and so on in ACI, all right? Okay, so we already did this. The last part is the threat protection. So imagine there's an angry employee. This is a use case that sometimes comes up. In microsegmentation, as you saw, I defined manually what the criteria to segment and isolate a machine was, correct? So in my case, imagine there's somebody that tries to access via SSH web server. And the problem is that one of those things are usually reactive. You get to learn that 4 months after, right? So one of the things we can do in the security integration with ACI is there's this thing called ACI remediation module for firepower. So one of the things you can do is if you detect a malicious pattern going on in the network, it can tell ACI the source IP of that attacker, right? And you can do the microsegmentation automatically. So again, for example, if you remember the example we just did, I went there and created an EPG, and I said, I want UACI to look in this network for any CentOS-based system. Here, what I can do is do nothing. I actually don't need to do anything. Just if FMC gets a malicious pattern, it will tell ACI what the IP of the attacker is, and it will automatically create that EPG and assign that endpoint to that group, right? So again, this is another way of using microsegmentation now with the security solutions. One of the things that we usually do is the threat protection. So imagine that employee that was trying to hack us got fired, of course. And then he started to join these hacker groups all of a sudden and starts to brute force into any of the servers. So one of the things we could do with titration as well is the forensic analysis. So you can come here into the security part, and remember you have security. Let me go into another tenant. This is multi-tenant, by the way. So remember, this captures information through time and several months, and you can go back in time anywhere you want. So if you, for example, need to do event type filter based on things like somebody trying to access with the wrong credentials constantly, or somebody's trying to sudo or gain privileges on an operating system that shouldn't, or if somebody's trying to change a file, or probably even if you have Meltdown or Spectre, right, which are some very well-known vulnerabilities on Intel. You can look for that at the operating system level by knowing every process that happened and the sequence of those processes. So again, this is very, very important. If you want to do some forensics analysis, every single thing that is running inside the operating system is being tracked, even all the way back if you may need to. So that's one of the other use cases that titration has. And the other one is the network performance, right? The network performance management. So the network performance management usually tells you how much bandwidth you're using per port, per switch, and so on. I think this got stuck. So far, any question? Nope? Still have less than 30 minutes, so hopefully I can still cover. I think I will be able to finish on time. But we have C1 coming up, then App Dynamics and Cloud Center, just to finish with. And this is taking a little longer. It's searching to 1 million flows, but this should be faster. But it just displays the same thing I displayed you before. You remember the process visibility? So it will just tell you what processes it is performing. Probably I'm just gonna show you as well the part in the performance part, dashboard. So as I said, you can look also in terms of network, what the distribution is, how much network latency is there versus how much application latency there is, right? So there's other use cases as well for tetration. All right, so if we keep going then, again, tetration is just a platform that will help you do microsegmentation on any cloud, any hardware, any hypervisor. It doesn't matter, as long as you have that software sensor, right? If you don't, then you can still complement it with other things like the network and so on. It can be SaaS or on-prem, and we don't copy the payload. We only copy metadata. So you don't need to worry about that bandwidth being massively consumed, right? The other thing that sometimes happens is that, remember our active-active scenario? Right? So if you want to achieve that, you remember that we did that multi-site VLAN extension, right? So I'm not going to show this due to time, but basically we'll have one of our partners, just as at the very beginning I showed Citrix and F5, of course, that I see that they are here. Avi as well is one of our partners. And basically they are a software-defined server load balancer solution. So if you have layer 2 extension, you could very much get away with a single name convention, two DNS listeners, and a single active-active type of scenario with global server load balancing. And again, you can move back and forth. We have this configuration working, but again, I'm probably going to try to jump into the other sections so that we can finish on time. But basically, again, as long as you have that layer 2 extension, here I have 2 servers, and in the other end I have other 2. And then the DNS listener available to receive those DNS requests. You can have an active-active scenario, again, with multi-site, with multi-pod, and then have this integrated in your front end, right? So just want to share with you that use case, which is, I think, very relevant for many of you that may want to do active-active scenarios. In the case of Avi, they also have this nice functionality of offloading for HTTPS. So that's another thing that I usually show, but again, I think I'm going to move on into the C1 piece of it. So the cost optimization and multi-cloud. The thing right now is the right sizing is very, very hard to do. So you have the on-premises environment, you have the public cloud. And then what do you want to move, how you will move it, and how much it will cost over there is sometimes a big question. I've had customers that have Excel files making sure that they have the full inventory of the virtual machines they want to move, and they pay exactly the same amount of money in the cloud, assuming that's the type of resources they need over there, right? So what we will see now is how C1 can help you moving those loads into the cloud. So this is, again, an agnostic platform that can cover not only Cisco, but also other types of solutions. And it's based out on a VM as well. So this is just our executive dashboard. Mainly, we can have this for cloud-based environments. We can know what actions we could take or how much it has cost, in this case, our cloud-based platform. And we can also do some on-prem dashboards in terms of how my infrastructure is working. But basically, the very first thing you need to learn about this one is that compared to tetration and AppDynamics, which use agents, C1 and Network Assurance do not use any agents, right? These ones are totally RESTful API call-based, right? So the very first thing you do as an admin, if you want to use this, is download the VM, and then you add your targets. What do you want me, C1, to monitor and give you advice on? You can monitor things like hypervisors, multi-hypervisors, or even bare metal environments now. You can also say, hey, I want my load balancer there. You can also say, I want my servers, either Cisco or HP. I want probably to go into the network with Arista or ACI, or even include tetration as part of the picture. We're trying to be as agnostic as possible. Obviously, the cloud part is there as well, right? Amazon and Azure and IBM. So once you have that, what C1 does, it builds a supply chain module on the right, and it will tell you day by day actions that you could take to optimize those costs and that usage. So in this case, it tells me I have a $9,200 opportunity if you listen to me, because there's 13 placement actions, 4 actions that you need to invest on, and 1 stop actions that we will see what it is about. So let's try to take a look at it. If we show all the actions, we will see there's different types of them. One of them is provision more disk, because there's congestion in this specific data store. The other thing we can do is we can start checking on scaling. So we can either scale up virtual CPU, or scale in virtual CPU, or memory, or disk. There's probably some wasting in the resources. Or we can say move some virtual machines from one place to the other one. So if, for example, you have a standard-based VMware today, if you have the regular license that does not include things like DRS, well, it doesn't matter. With SIEM1, you could do something very similar. Not only will we tell you what you could optimize based on the usage of your infrastructure, but you can go ahead and say, apply selected. So what this should do is this would come here to VMware and then move based on the recommendation from the congested server to the less congested server. Make sense? Yep. So again, it's not only about reporting, it's also about automating that right sizing for you. So if we go back here, again, there's all sorts of categories, right? Placement, provisioning additional disk, because probably here it's already congested, as we saw. So we can see what the reasoning behind that congestion is. So, for example, this is my hyper-conversed environment. I can see what the utilization is. 6,789% utilized, right? So probably I need to do something about that. Anyways, the idea with this is it also calculates the amount of money it would traditionally take you to replace or fund those extra resources. Then the other part that I consider very, very useful is the way, as we said, we can migrate to the cloud with more confidence. So for example here, I have all my VMs. Let's actually look for virtual machines. And I may want to move all those VMs to the cloud, to Amazon, let's say. So I want to say migrate to the cloud. What will happen is C1 will gather all the information from vCenter and all the historic information I have been getting from this analysis. And then it will show me what are the steps I need to move to the cloud and how it's going to optimize that movement. So for example, once it displays, it should take a few more seconds. Saving. There it is. So you will see that there are two different columns. The first one is the one that you could probably do if you didn't have C1. What would happen is you would have the full inventory, and you may have over-provisioned or under-provisioned machines. In this case, I have 0 machines out of the 168 I have with under-provisioning resources. But I have 163 that have more CPU or more memory or some more resources than what they actually need based on the workload. So if we just went ahead with the inventory-based migration, we would do exactly the same mistake. We will be buying 163 machines with more resources that they need, and it would cost us $14,000 to go and run that way in Amazon. If we listen to C1 is going to be constantly updating and making sure you right-size your workloads, and you will have 0 under-provisioned or over-provisioned machines and only paying $5,000 in this case. So just by the very, very first step, it's already telling you, well, you're going to save with just this initial sizing, because I'm going to tell you exactly what you need on the cloud, right? And it leverages also some resource instances, advisories, and all that, right? So you may have then the full list of why it is coming to that conclusion. So you can go per machine and see why or where it is placing it, which region is the one that is more effective, and so on. Go ahead. Can you repeat the question? Oh, that's a great question. So Amazon in particular, the way I tied it, the question is where the numbers coming from, right? So what it's doing is Amazon, when I put my cloud account, it has a sizing and a price list for everything you consume there. Every time you buy something, it always has a price. So when I linked my account, what it did is it pooled all the regions that were assigned to my account, right? And then based on that, it compares what load it would need to run on Amazon, and it simulates, based on those prices from Amazon, the cost for each scenario. What's that? On all the equipment, yeah.
Your own equipment for your private cloud.
Yes, of course. That's what it does. It takes your own equipment and then it goes to the cloud. If the question is, how does it take your own equipment cost, it's just the regular basis, well, what we have seen in the world, that a CPU cost, a memory cost, or a disk cost. You can always optimize or adjust those costs, by the way. So if you want to, you can do it your own way, because probably it's not reflecting everything you have in mind for your costs. Yeah. Sorry, I didn't get the question before. So again, this is extremely useful. The other part that I find useful, it will tell you obviously all the actions that you will need to do to move to that cloud. And obviously it will not perform that for you because it would need to convert probably to every single machine to the destination, but at least you have a great understanding of how this could work, right? The other thing is, once it is on the cloud, it will still give you constant recommendations. So for example, if a machine is existing on a specific size, you can obviously scale it out, or I'm not getting any recommendation on that, but if you get a new region that gets better pricing because Amazon prices are dynamic, it can tell you, hey, you know what, in this region now it is cheaper, right? You can also automate everything. Instead of saying, you know, every time there is a thing you want me to do, C1, what I can do is come here and say automation policies. And I can say, for example, in the same case I did with the vMotion, I can say, next time you tell me there is a move recommendation from one server to the other one, just do it. Don't ask me, right? So you can come up with some nice sort of things so that you can just leave C1 to do everything automatically for you and run the data center by itself, right? The other part is the placement. So imagine you're constantly getting new and new VMs. You can tell you can tell C1, let's say, for example, here I have a template for a web server. I want to create more web servers. I can ask C1 what the best possible placement would be based on the current usage. So for example, if I have a saturated server or a saturated region, it can tell me, well, this is the best possible place if you want to do this new implementation for this to run on. In this case, it's obviously HyperFlex, and this is the data store that is less congested, right? So you get the best CPU performing machine plus the less congested data store, right? So this is something that is also very, very cool. Any question? Nope? All right, so let's move on then. We have probably around 10 more minutes. So again, C1 is totally agnostic to the hardware, totally agnostic to the cloud. You don't need to install any agents. You just turn on the virtual machine, and around 15 minutes after, you will start to get all this type of information based on your environment, right? The other thing is user experience and automation. This is the very, very last part of this. So AppDynamics is a solution that helps us. Imagine this application starts getting some performance issues. If my users cannot do a checkout, for example, I'm going to lose money, right? So AppDynamics monitors the full experience of the user all the way from the application to the database, probably, regardless of the cloud they live in. Again, totally agnostic to the hardware, totally agnostic to the type of solution you have, or to the cloud. So let's go here. So first of all, this is the main view. This is an application that has all the different layers. If you see, this is very, very focused on the application itself. It's not telling me much about the infrastructure. It's telling me how the web servers are connecting to the inventory. For example, if I make a purchase, I want to know what the inventory looks like based on the Java system I have, or the login services, which is a Python service, or if I have, for example, fulfillment, or the services in terms of Visa for charging the credit cards. All of this logic of the application is displayed through this main dashboard, right? So from there, I can normalize things. I can say, well, you know what? There's some errors, or there's this unexpected behavior with higher latency or higher core error count. So you can then, from there, start drilling down. The very first thing with AppDynamics is that you can monitor every business transaction. This is extremely useful because if you do checkout, we will monitor it for you. If you do anything, we will monitor it based on those business transactions on your application, right? So we can know how the life cycle of that business transaction looks like coming from end to end. The other nice thing we have is that we can start on the very front, let's say with user experience. So if I have an online retail store, and this is HTML based, I can see several things. I can see a dashboard on which browser my users are accessing from. Is it Chrome? Is it Safari? Is it Firefox? I can see if there are any errors in different browsers. Probably I need to do some compatibility testing with other browsers. Which regions they are accessing from, and so on. So this is extremely, extremely useful, again, in terms of you get to see pretty much everything that happens all the way from the user to the back end, right? And this is also available, by the way, for mobile applications. So you can do exactly the same thing. For example, here, if I do it, let's say, on iPhone or iPad, I can see where they are accessing, what the latency is in one country or the other one, and if it's an iPhone 6, an iPhone 7. The nice part of this is, for example, crashes. You even get to see that level of information here. So, for example, have you ever experienced any crashes in your apps, in your phones? I think you have, right? All of a sudden they close. So the nice part about App Dynamics is it tells you what the user did. For example, in this case, they logged in, they saw the list, they viewed the cart, and when they tried to change the address, it failed. And this was a specific library that failed. So you get the visibility all the way to that point, which is somehow very, very hard to get, right, otherwise. Then you can move on and say, well, I want to probably monitor the database, very, very back-end, right? And in this case, I can see the top queries that are probably consuming most of the CPU within that Oracle server, right? So we should see right now the top execution queries that are consuming my CPU, right? And so on. And in the server level, for example, we can even see other things like, I think I have some containers over here as well. So for example, I can see here the main dashboard for the average load, the availability, the CPU, the memory, the network, the properties, the volume. So there's all sort of monitoring, even at the container level. So again, this is extremely detailed so that you can not only have the application view, but also the infrastructure view, right? With that being said, if we come into or go back to the slide, for us, the idea is how can we make that application performance better with other solutions? We already have a great tool with App Dynamics that can monitor every single thing. Oh, and by the way, I almost forgot. You can then get dashboards specifically for the people you want to understand or learn based on probably executive decisions. So let's, for example, think about the business impact dashboard. I think it's this one. So imagine there's somebody that is not technical. They don't want to know if there's a query that is probably consuming more CPU or less CPU. But then there's somebody that wants to know what the impact on my business is. So you can get some specific dashboards. This is not the one I wanted. But you can get very, very specific dashboards based out on those business metrics. So conversion. OK, here it is. So for example, in my store, I want to know how many users hit my page, and from them, each action, how many users are continuing that path. And the nice part is that if they fail at checkout, if all of a sudden I click checkout and I cannot pay, that's a huge problem for me as a business owner. So the nice part with this is that you can understand if the checkout failure was due to an error, if it was, you can drill down if it was a server or network or application error and so on. So again, you can just start displaying the information you need based on your users' needs. So this is extremely useful if you're making money with your applications. Going back to Cloud Center, which is the last piece of the puzzle, Cloud Center is the way we provision single-click experiences for provisioning new loads on any cloud, right? So this is totally agnostic, again, to the hardware, totally agnostic to the cloud. And for us, the idea is, as things get multi-hypervisor, multi-platform, and multi-location, we want to make sure that we can orchestrate services centrally. And that's where Cloud Center comes into play. So if we need that single-click experience, and we want to model a service once, but deploy it anywhere, Cloud Center may be very good for it, and I'm going to show that in a second. The other thing is that it helps you limiting your budget in terms of the public cloud. So for example, if I don't want to overspend money based on a per-user, per-tenant model, I can also define this as well within Cloud Center. So this is Cloud Center, and basically what you're doing here is, one, aggregating all your multi-cloud resources. I need to log in again. Cloud Center may be on-prem or SaaS-based, and the idea for us is, one, as I said, first give me your clouds. Tell me your on-prem, off-prem, or container-based clouds, so that I can aggregate all those resources together, right? When I have the resources ready, I can start modeling my applications or my services, and then the user will get to choose which cloud they need to provide them on. So in my case, I have different clouds. I have Amazon, I have Kubernetes, and I have VMware. So all I need to do is create my catalog, my application profile. How do I create this? I model, as I said, the service once. And how do I model it? Well, basically I need to say, for example, in this case, I want to have a front end with IIS, and I want probably to have a back end with MySQL, right? One of the nice things about this is that you can tell it, for example, I want a minimum in the web server layer of 1 node, and I want a maximum of 10. Why would that be useful? Because then you can get scaling policies. So for example, imagine at some point in time, you get to December, and this is an online retail store, so hopefully they will buy Christmas presents, right? So I can tell Cloud Center in this case, if you detect that the CPU utilization in one of the instances is bigger than 85%, create another instance. Remember I said the minimum is 1, maximum is 10, right? So you can be scaling out based on the attributes or the criteria that you think should be contained there, right? But also, if the CPU drops to less than 25%, you don't want to leave those instances on, so you can shrink it, right? So the idea for us, again, is to make sure that you can scale this horizontally in this case, the best possible way. And if we do that, the load balancer should be in front, right? I guess that would help us so that we can scale through time if we need to, right? What else does Cloud Center does whenever you model this service once? Firewall rules. If you have ACI, the firewall rules will be contracts, and those will be automatically created for you. If not, no problem, it will be host-level based firewall rules, right? The other thing you can do is migration. I want to move from one cloud to the other one. Where is my data in Amazon, in S3? Okay, well, just give me that location so that I can copy those data or that data and put it on-prem whenever I move it on-prem, for example, right? So this is, again, very, very useful because you're modeling this thing once, and you can install or integrate your orchestration systems as well. So if you have Chef or Puppet or Ansible, you can import those already pre-existing workflows or playbooks into this type of systems, right? So once you do that, and you create the service, you can then come here and say, I don't know, I want to do a Cisco Live deployment. By the way, you can create security policies or aging policies, which means if a machine is not doing anything for 30 minutes, you can kill it automatically. C1 could do the same thing. So that's very, very good, again, for efficiency in terms of cloud-based costs. And then you can tell it here, well, you know what? I want this on Amazon. All right, so let's put it on Amazon. What it will do is it will grab all the costs from that, just a C1, right? It will grab all the costs and it will give me the catalog of which sizes I may place it in, right? You know what? It may be a little expensive. So let's go to VMware. I have VMware on HyperFlex, VMware with ACI. So I created a couple of shared sizes and I put my own prices. Again, these prices are totally defined by you in your private cloud, obviously, right? So in our case, I want to create it in Amazon. But again, it's the same model. I don't have to invest on expensive services. Oh, I thought I had put a name to it. So next, Amazon. By the way, before I move on, this integrates fully with ACI. So if I have ACI, we should see our tenants. Select, use ACI extension. We should see everything we created from ACI. So I have here all my options with the switches. I have SCVT Inc. So it can pull or it can pull every value from that ACI installation if you want. Or it can provide it by default, as you wish. So I will just put this on Amazon, on the very small shared size. I will say, oh, it does exist? Really? So it did deploy it. Let me check. Oh, here it is, yes. Yeah, sorry, I think. So it got auto-approved, and it is already loading, right? So we should see this machine in less than 30 seconds already in Amazon. One of the other things that you will see this does is that you can access SSH directly from here. You don't need to save this .pem keys, so that becomes sometimes a mess. And all the invoice is aggregated directly here. So for example, while this gets provisioned, if I go into my environments or my regions, actually my regions, and I want to see how much, actually my boss was here a few minutes ago, so I thought it would be good to see, for him to see how much these demos are costing. So I can come here and I don't need to go into the dashboard. I can here see how much it's costing every single month per cloud. If I have Google, if I have Amazon, if I have IBM, it doesn't matter. I will get the aggregate of all the invoices here, right? This is also multi-tenant, by the way. So if you want to see, for example, in the reports, you want to see how much I am spending per user or how much I'm spending per application, in which cloud I'm spending more, in which cloud I'm spending less, this is also very good. And it can optimize those costs. So this should be already done, hopefully. Well, it's still in progress. But one of the things I wanted to show you, we go to the servers, is you can start mixing and matching technologies. So for example, now, if I come here into my, my Cloud Center environment, I'm starting to get lost here, okay. If I go here into my Cloud Center environment, the nice part is that I can now automate other things as well. So I'm gonna use this existing Amazon VM technology, VM. And if you see, I can install from here App Dynamics agents or titration agents, right? So if I want to do that, I just have to go here, see that right now, at least, App Dynamics only has 2 servers monitored. So this is living on Amazon. I will say yes. This is living on Amazon US East Virginia. So if I want to monitor again the application end to end, regardless of the cloud it lives on, I just can install the App Dynamics agent or the titration agent, and it should appear now on App Dynamics in a few minutes. Okay? So again, we can start being more powerful if we start integrating things. Things like, for example, while this gets loaded, App Dynamics and titration, right? I can start getting the full correlation and security based on zero trust, even on the cloud, right? Or I can have CWAM. So CWAM can be integrated to Cloud Center to ask CWAM in this case, which is the best place to load that new application I selected. Or then we can also do a scale in and a scale out. Remember, CWAM does a scale up and a scale down at the VM level. But Cloud Center can do it scale out based on instances level. So now you have this full way of scaling one way or the other one if you integrate both. And the other part is that we can monitor everything more consistently. So App Dynamics and ACI, as well as Network Insight resources, are two things that we can now integrate into ACI. So for example, if you want to correlate how the network is affecting your application, you can see it through ACI with a plugin we have. Same thing with Network Insight resources. If you want to see every flow on the ACI level without even going to titration, you can also do that through ACI applications. So again, there's lots of things you can do so that you can still mix and match technologies if you have 2 or more Cisco ones, right? Let me show you that in a sec. So this is already running, by the way. This is the one that we had provisioned. From here, as I said, I can just SSH into my machine, right? And I can also probably get to see the instance of my web server already running in the cloud. Actually, let me go here, deployments, Cisco Live. So if I go access public SBT marketplace, I should see that the application is already running on Amazon, right? So that's more or less the idea. All right, last part I will close with is what happens when you have other technologies, right? So for example, if you are thinking about putting NSXV and ACI, how would you mix them both together? Well, remember ACI is a great solution to automate underlay as well as overlay, right? We can extend layer to anywhere pretty much. So one of the things we have seen is basically you want to make sure you have a single pane of glass for your network. If you're thinking about both, how can we benefit both worlds? Well, basically, if we have a single network that does both, overlay and underlay, we can probably be more consistent in troubleshooting and we can secure everything more consistently. But many of our customers have NSX because they liked microsegmentation done there. So maybe the VMware admin is the one that will lead the microsegmentation. So if you want to do that, you can do that still. NSX does not need to run the overlay and the VXLAN part if you want to run microsegmentation. So again, one of the nice things is if you decide to run ACI as an underlay and overlay and have NSX as the microsegmentation piece for you, the nice part is that, again, you don't need to segment administrations. And the other nice part is that you will not need dedicated servers to perform routing functions and switching functions, which is something VMware demands today. ESGs, distributed routing, and so on, they require x86 dedicated functions or servers for the network. You already have a network, so you can just leverage that. You can install the plugin locally, and you can, again, do both, right? So I had that demo also here, but I think I'm going to get kicked out very soon. So just for you to know, you have on vCenter an ACI plugin, and you also have a firewall plugin with NSX. So you can run both. It's perfectly fine. But again, one thing that we are doing better or to enhance NSX is to make sure you have a single network. It doesn't matter if it's one hypervisor or one the other one. You can still integrate your NSX microsegmentation if you want and keep it there. That's totally fine, right? So just want to cover that real quick. All right, so I think I need to get going, but we pretty much covered a lot today. and I really, really thank you for staying here the full time. I know it's not easy to be talking for 2 hours, and it's even less easy to listen for 2 hours. So hopefully this helped you to get a full understanding of all the solutions and what the business value or the benefits are. So I'm going to obviously share this slide with you. And the YouTube channel is right there in case you want to follow these presentations at your own pace. And there are some other nice web pages that we do. So any questions, please follow it up with WebEx Teams. And please fill out your survey, because otherwise they will not invite me next year. So fill out your survey, and I really, really thank you for staying here. Hopefully it was useful. So thank you.